Again, this is another limiting reagent type calculation, except for now we have to actually find the mass that could be made in this reaction. So it's a little bit different than other variations. And again, this is going to be a little bit harder than the problems you're going to see on the exam because they don't give you the balanced chemical equation. So we're going to start with methane. It's going to react with oxygen to produce carbon dioxide and water. We need that balanced chemical equation. We come in and take a look. Carbon is balanced at 1, got 4 hydrogens, so I need 2 here. Now everything's balanced except for the oxygen. I've got 2 oxygen here, 2 oxygen here for a total of 4. I need to have a coefficient of 2 there to let oxygen balance out. Now we can take a look at the reaction to see that I've got 1.12 grams of methane react with 2.4 grams of oxygen, and we want to know the mass of carbon dioxide that can be made. So again, limiting reagent calculation. We're going to go from mass to mole, and then we're going to go use the mole ratio to get moles, in this case, of CO2, and then we can get the mass of CO2 out of that. So we're going to go to the mass of methane, the mass of oxygen, to moles of methane and oxygen, and then we're going to use the mole ratio to go moles of carbon dioxide so that we can find the limiting reagent in this calculation. So we'll start with the methane. I've got 1.12 grams, and of oxygen, I've got 2.4 grams. All right, oxygen, 32 grams per 1 mole. Methane is 16 grams per 1 mole. So I've got 0.07 moles of methane, and I've got about 0.075 moles of oxygen. We can't compare the numbers here because remember, they react in different amounts. I need 1 cup of methane for every 2 cups of oxygen, right? 1 mole to 2 moles. I want to convert them both into moles of CO2. So we know for every 1 mole of methane, I'm going to make 1 mole of CO2. That's what the molar coefficients tell us in the balanced equation. Whereas for oxygen, I need 2 moles of oxygen for every 1 mole of CO2. So we have approximately 0.07 moles of CO2 that could be made there, whereas we only have about 0.0375 moles of CO2 that could be made from the oxygen. Now you can see that's our limiting reagent because that's the smallest number of moles. So we only need to carry forward with that number of moles because the reaction stops there. That's going to limit the mass of CO2 that we can make in this reaction. So bring in the molar mass. I know 1 mole of CO2 is 44 grams. So we should make about 1.7 grams of CO2. I would say 2 significant figures, because if we look at our initial mass of oxygen, there's 2 significant figures there as well, and that's what we used going forward. So 2 sig figs there, we should have 2 significant figures in our final answer.